Okay, the next thing to learn is the grouping of symbols. Grouping of symbols. Like I said, symbols are referred to as the representative of an element. Instead of writing the element in its full form, you can represent the element in its symbol. But these symbols are categorized in 4 main categories. So having it here, elements are symbolized into 4 main categories. The first one is called first letter only. Example of element in which you represent that symbol with our first letter. As you can see, boron as B, carbon as C, fluorine as F, hydrogen as H, iodine as I. We have other elements, but I just give few out of everything. So there are some elements that they are categorized based on their first letter. So if you want to write them, you will write the first letter to represent them. And the second category is elements with the first 2 letters only. Element that has the first 2 letters only. For instance, helium starting with He, and note something, the first letter is always starting with a capital letter, while the second letter comes in a small letter. You don't write it this way. Not accepted. Okay, and that case here is lithium, which is Li, and that case here is beryllium, which is Be. We have neon, which is Ne. We have aluminum, which is Al. And that category, which is the third category, is when element is represented with first letter and any other letter except the second letter. That means apart from the second letter, they make use of either the middle letter or the last letter to represent the symbol for the element. If we consider this, we have magnesium. They make use of the third letter of magnesium and the first letter to represent magnesium. We have chlorine. They make use of the first letter of chlorine and the third one. Likewise, chromium is Cl. Manganese, Mn, zinc, Zn. And the fourth category is the one that deals with their Latin name. There are some elements in which they were formerly called a Latin name before they have a new name. A typical example is sodium. Sodium is formerly known as natrium. Now it is symbolized based on their Latin number. Based on the Latin letter. So sodium, which is natrium, is now written as Na. Iron, which was formerly called ferrum, is now Fe. Copper, which was formerly called cuprum, is now Cu. Gold, which was formerly called Horium, is now Au. Silver, which was formerly called argentum, is now Ag. While tin, which was formerly called stannum, is now Xm. So these are the four category elements are represented. Okay, the next thing we're going to consider is valency. What's valency? Most of the time, valency is always referred to as the charge on an atom. Valency is the combining power of an element. Before an element can combine with another element, they must be in a proper valency. For instance, let's give an example. A quick one, hydrogen wants to combine with chlorine. So before we combine hydrogen with chlorine, we must firstly know the valency of hydrogen. So if hydrogen is given to be +1, then chlorine is given to be -1. When you try to cross multiply the valencies, it's going to turn to HCl. So that's the essence of why we have valency. So that's why we said valency refers to as the combining power of an element. Now we are going to learn how the valency of a metal should look like, the valency of a non-metal, and the metal, likewise the valency of a noble gases. So coming down here, a metal. Most of the time, the valency of metal is determined by the atom's shell electron. Valency of element, rather, is determined by the atom's electron. For instance, let's consider chlorine. Let's use sodium first. The atomic number of sodium is 11. Now, when you want to arrange sodium on its atom, because on the atom we have what we call the shell, the K shell, the L shell, the M shell, and the N shell. So if I want to arrange everything, the K shell can only accommodate the maximum of 2 electrons. The L shell can only accommodate the maximum of 8 electrons. Now if you look at this carefully, we already add 2 and 8. That's making 10. So I'm left with just one more. So that means sodium has a valency of 1. Okay, let's consider another one. I'm coming, a quick one. Let's assume we are dealing with magnesium. Magnesium is number 12. When you try to arrange them based on the shell, the K, L, M, N shell, magnesium has 2, 8, 2, because our K shell can only accommodate the maximum of 2 electrons, the L shell 8, and the rest of them can accommodate 8. So that is why we have 2 plus 8 making 10 plus the rest plus the 2 making 12. So the valency of magnesium is 2. And let's consider one more. Let's consider boron, for instance. Boron is symbolized as B. Then the atomic number is 5. When you try to arrange this on the K, L, Mn shell, the K shell accommodate 2, the L shell accommodate 3. Because the maximum electron we can see on the K shell is 2, then the L shell is left with 3. So that means the valency of boron is 3. But I need you to understand something. Anytime an element has the valency to be either 1, like sodium, or 2, like magnesium, or 3, like boron, we usually refer to them as metal, because on the long run they will give out the electron. Okay, a quick example of this. Let's consider sodium as an example. Before sodium can turn to an ion, it's going to give out 1 electron, because at the valence electron 2, 8, 1, the valence electron says it can only give out 1 electron, then you see it as Na+. So in this case, we say the valency of sodium is +1. Okay, let's consider magnesium. Magnesium has a valency of 12. It means it can only give out 2 electrons. Why? Due to because on the arrangement on the KLMN, we have it as 2, 8, and 2. So this is the valency. So it means when magnesium give out the 2 electrons, it's going to turn to Mg2+. So the valency of magnesium is 2+. Likewise, when you consider boron, which is number 5, and that's 2, 3, so the valency is 3. That means it's going to lose 3 electrons, and that will be written as B3+. So the valency of boron is +3. So any element in which the valency ranges from 1 to 3 are always giving out 3, and that is how we write it as +3.